Buckle up and dive into the jaw-dropping world of oil tanker construction. We're talking about very large crude carriers, or VLCCs, the titans of the sea. Imagine a ship longer than 3 football fields, a floating fortress of steel designed to move over 2 million barrels of oil across oceans. These vessels are the lifeblood of the global economy, keeping entire nations humming. So how are these giants forged? We're about to break down every mind-blowing step, from a digital concept to a colossal reality, revealing the fusion of raw power and precision engineering. The journey begins with a massive design marathon. Using advanced CAD software, engineers sculpt the hull form, running countless computational fluid dynamics simulations to optimize for fuel efficiency and seakeeping in harsh conditions. Every curve is refined to minimize resistance, saving tons of fuel over the ship's lifetime. This isn't just about efficiency, it's about safety. The design must adhere to strict international regulations like MARPOL and SOLAS, governed by classification societies. This digital blueprint, a complete product lifecycle management file, contains every single one of the 110,000 parts. Each gets a unique barcode, enabling an automated tracking system that flags misplaced components instantly. This master file is the single source of truth that guides the entire 16-month build with millimeter precision. With the design locked, construction begins. The ship is built not as a whole, but in grand blocks, massive prefabricated sections that can weigh up to 1,000 tons each. It all starts with high-grade, thermomechanically controlled steel plates. These are fed into automated panel lines where CNC plasma cutters, guided by the digital blueprint, slice through 50mm thick steel in seconds. The cut edges are then perfectly beveled. This preparation is critical for achieving deep, strong welds that ensure the ship's structural integrity against the immense forces of the ocean. Steel sheets are welded together to form the hull panels. A thin layer of sand, or flux, is poured onto the seam. When the welding torch hits, the flux melts into a protective slag, shielding the molten weld from atmospheric contamination and producing cleaner, stronger joints. Robotic welders then lay continuous, flawless seams, each one meticulously inspected with X-rays to hunt for any hidden defects, ensuring a hull that is absolutely uncompromised. The tanker's skeleton begins with prefabricated structural beams, forged from thermomechanically controlled processed steel for superior strength and weldability. These colossal components are positioned by massive robotic arms with millimeter precision, forming the foundational grid of the ship's hull. Each beam is meticulously aligned using laser guidance systems, cross-referenced by total station trackers to maintain accuracy over tens of meters. Simultaneously, an operator runs real-time stress simulations, confirming that the complex load distribution across the entire structure meets stringent classification society rules. This rigorous process ensures the tanker's framework can withstand the immense dynamic forces of rough seas and the static weight of its massive cargo loads. To manage stability, ballast tanks are crafted. Steel plates are submerged in water, while a plasma cutter carves intricate hole patterns. This underwater cutting technique minimizes heat distortion, preserving the steel's structural integrity. These precisely engineered holes serve a dual purpose. They act as water passages for rapid ballasting and deballasting, while also reducing overall structural weight without compromising strength. The plasma torch reaches an astonishing 20,000 degrees Celsius. This extreme heat enables ultra-clean cuts that dramatically improve the steel's fatigue resistance, a critical factor for a vessel designed to last for decades. A key safety feature mandated by international law is the double hull design, which adds a vital protective layer to prevent oil spills in the event of a collision or grounding. Workers expertly weld the inner and outer skins together. Then, a specialized epoxy sealant is applied between the layers, creating a monolithic, corrosion-resistant barrier for ultimate leak protection. Once complete, this entire section, known as a grand block, is lifted by massive gantry cranes and slotted into the ship's growing framework. At the heart of the vessel, a 10,000 horsepower, 2-stroke crosshead diesel engine, larger than a house, is aligned with micrometer precision to the propeller shaft. To achieve this, The engine's mounting bed is machined to tolerances of just 0.1 millimeters, ensuring perfect power transmission and minimizing vibration. Alongside the main engine, 3 auxiliary diesel generators are synced to provide a constant, reliable stream of electricity for lighting, advanced navigation computers, and critical ventilation systems throughout the ship. With the superstructure in place, the tanker's circulatory system comes to life. Over 10 miles of specialized piping are fabricated and installed, a metallic web connecting every critical system. Each pipe is bent with computer-controlled mandrels to exact angles, ensuring a perfect fit within the ship's complex interior. To guarantee leak-proof integrity under immense pressure, welders use automated orbital welding machines. These devices create flawless, seamless joints, a critical step for safely transporting volatile cargo. The pipes feed into 12 enormous cargo tanks, which together can hold 14 million gallons. These tanks are equipped with internal heating coils that warm viscous crude oil to 60 degrees Celsius, making it fluid enough for easy pumping. An inert gas system is also installed, blanketing the cargo to prevent explosive vapors from forming. While the internal systems are fitted, the exterior is prepared for its protective skin. The hull is ground smooth with robotic grinders to a specific surface preparation standard. Then, it's coated with a sophisticated 3-layer epoxy paint system, engineered to resist saltwater corrosion for 25 years. The final layer is a specialized anti-fouling coating that prevents marine growth, improving fuel efficiency. Technicians use ultrasonic gauges to meticulously measure each coat's dry film thickness, ensuring it complies with strict maritime standards. In total, 38,000 gallons of paint are sprayed using high-pressure atomizers, creating a uniform shield against the harsh ocean environment. After 16 months of construction, the tanker is ready for its ultimate test: rigorous sea trials. These trials push the vessel to its limits, measuring its turning circle, crash stop distance, and overall maneuverability. Hull stress tests, propulsion performance checks, and emergency spill simulations are all conducted. In the engine room and on the bridge, engineers fine-tune every system, from the main engine's waste heat recovery to the navigation suite's radar and GPS. Once every test is passed, the vessel earns its certification for global voyages, ready to haul oil across the oceans for decades. From digital blueprints to a colossal steel behemoth, the oil tanker's production is a symphony of precision engineering, advanced robotics, and irreplaceable human craftsmanship. Now you've seen every secret step that turns raw steel into a maritime giant that fuels our world. If you have any questions or comments, please leave them below. Your input matters. Share your ideas for our next video in the comments, and we will recognize your contribution. Thanks for joining us on this exploration of the fascinating stories behind everyday things. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching, and if you want to learn more, click the next video right here.